Hey everyone, and welcome. Today we are diving into a huge challenge in the machine learning world. How do we stop reinventing the wheel and actually start building AI that's scalable, repeatable, and most importantly, trustworthy? So if you've ever felt like your ML projects are just kind of stuck in a loop, then this one is definitely for you.
You know, for so many data science teams, the whole path from just an idea all the way to production, well, it feels less like a straight line and way more like a maze. It's just filled with all these dead ends, so much repetition, and these really frustrating bottlenecks that just slow everything down.
So let me just ask you straight up. Does this sound familiar? You build this amazing model, but then trying to get it to run anywhere else, or heck, even just trying to rerun it yourself 6 months from now, feels completely impossible. It is such a common frustration, and trust me, you are not alone.
These right here are the classic signs that you're stuck. And we've all been there, right? That whole, well, it works on my machine problem. The endless copy-pasting of data prep scripts. And oh, that nightmare scenario of trying to reproduce something you did last year and getting errors from some missing library. This isn't just inefficient. It's a huge, huge risk to your projects.
So, how do we get out of this maze? Well, the answer isn't some secret map. It's about a totally new way of building. It's all about thinking in terms of modular, reusable building blocks. You know, kind of like Legos.
Just imagine for a second, what if you had a box of Legos, but for machine learning, where each individual brick does one thing and it does it perfectly. You've got one brick that cleans your data, another one that trains a model, and a third that evaluates it. They're all standardized, totally reliable, and designed to just snap together. This is the core idea we're going to explore, and believe me, it is a game changer.
And here it is, the official name for these Lego bricks in Azure Machine Learning. They're called components. So a component is just a self-contained, reusable piece of code that does one single step in an ML workflow. This little guy is our ticket out of the maze.
Okay, so what's actually inside one of these building blocks? What makes it tick? How does it guarantee that it's going to work the exact same way every single time, no matter who runs it or where they run it? Let's peel back the layers and take a look.
All right, so this really breaks down the magic. There are 4 key parts. At the heart of it, of course, is your code, your Python script, the thing you're an expert at. But wrapped around it are 3 absolutely crucial things. You have defined inputs, so it knows exactly what to expect. You have defined outputs, so the next step knows what it's getting. And most importantly, you have the execution environment. This means it packages up all the software it needs, all the specific library versions, so the component brings its own toolkit. This is what eliminates those dependency headaches forever. And this visualizes it perfectly. A component is like this perfect little self-contained box. It takes a specific input, runs your code inside a totally controlled and consistent environment, and then it produces a predictable output. It's simple, it's powerful, and it's completely portable.
Okay, so having individual bricks is great, but the real power, the real fun, comes when you start connecting them together. So let's see how these components build into something way bigger: pipelines.
This is where that Lego analogy really just comes to life. You take your individual components and you literally snap them together to create this end-to-end automated workflow. In Azure ML, we call this a pipeline.
Here's a super simple example. The output from your data prep component, let's say it's your clean data set, it becomes the direct input for the train model component. And then the trained model that it produces flows right into the evaluate model component. See how that works? Each step is standardized, reusable, and version controlled. No more messy handoffs between steps. And the best part is, it scales beautifully. I mean, this workflow might look complex, but you can just think of every single box in this diagram as one of our standardized components, whether you're pulling in data, training a model, or deploying it. By breaking the process down into these components, you can orchestrate these incredibly sophisticated MLOps workflows with total confidence.
So you've built all these incredible reusable components and pipelines. Now what? The next logical question is, how do you share them across your whole organization so that you can really scale their impact and make everyone's work faster? The answer is Azure ML Registries. The easiest way to think about a registry is like a shared central toolbox for your entire company's machine learning Lego bricks. It's one single place to publish, find, and reuse all the best, most trusted assets your organization creates. And this, right here, is a total game changer for teamwork. I mean, imagine cutting your model development time from 6 weeks down to 2, simply because the data cleaning and feature engineering components were already built, tested, and just waiting for you in the registry.
Instead of every team solving the same problem again and again, they can just pull the official version. This is how you standardize best practices and massively speed things up.
Okay, let's connect all this back to one of the most important goals in our field today, which is building AI systems that are not just powerful, but also responsible and trustworthy. And as you're about to see, this whole component-based approach is absolutely fundamental to making that happen.
So here's the really crucial point. This component approach has massive implications for responsible AI. Because each component locks in its code and its environment, you get perfect reproducibility. This means you can trace a model's history all the way back to the exact data and the exact code that created it, which is essential for things like audits and debugging. And by using standardized components from a registry, it's so much easier to enforce your company's governance and security policies everywhere.
And this quote from Mihaela Vorvarenu at Microsoft Research just captures the whole spirit of this perfectly. Building AI responsibly isn't just a technical problem. It's about collaboration between all kinds of different experts. And shared components and registries, well, they provide the technical foundation that makes that deep, early collaboration actually possible. So there you have it. We've gone from a tangled maze to a clear, powerful set of building blocks. By using components, you can build faster, you can collaborate better, and you can create more trustworthy AI. So the only question left is this. With this new power, what incredible problem are you going to solve first? Thanks for tuning in.